This video is going to help you with activity 4.2 model creation, and this is one of the assignments for readiness training, and as well as being an activity that you'll have students do later on in the school year when we get back into the swing of the 2018-19 school year. So when we look at this model number 1, we have an isometric view with dimensions tied to it. Note that this is not a practice in engineering to place dimensions on the isometric view, but it is there to just kind of provide a good view of at least 3 sides of the part, and then being able to have some dimensions tied to it. All the dimensions are in inches, and a few key dimensions I'm going to start off with. I'm going to do a subtractive modeling process first, and we'll see which one would be the efficient method. So here I've got a 4-inch wide. If I was to ignore this square tab on the side to model this main piece, I'm going to kind of ignore it for right now. 4 inches wide by adding these 2 dimensions up, so 2.5 inches tall and then 2.5 inches in depth. So I'm going to start with going into Inventor, starting a new part, or if you go to if you happen to hit the shortcut menu up here to create new file, you want the standard IPT, so we will never utilize the sheet metal IPT file in the IED course. So standard IPT, we'll create it, say start 2D sketch, and I always choose, for the most part, unless it's orientation of a part is a little different, I always tend to use the XY plane as my modeling principal plane to work from. So I'll start off with a rectangle, and making sure to always constrain to the origin is one of the best modeling practices, because then that way this geometry gets locked into space. I'm just going to draw the shape for right now, kind of roughly to the size that we need it to be, and I'm going to click on dimension and dimension this width to be 4 and the height to be 2.5. So you can see that when I constrained it, there's a few things that are helping you here. One, I want to show you, as you look down here in this bottom left hand corner, when I move out of the drawing area, it'll say select geometry to dimension, little notes there to help you along with your modeling, but also looking down here in the bottom right hand corner saying it's fully constrained. Typically your geometry will turn up like a purple or a bluish kind of color when it's fully constrained rather than the green, and when I have that fully constrained, then I'll know that I've got all the dimensions that I need. I can click on the little home button on the view cube to kind of size up the sketch to the size of the screen. I will extrude. You can choose which direction, either direction 1 comes at you or direction 2 goes away from you. And I'm going to put in 2.5 for that particular depth. Say OK, and there we kind of have our part. Now I usually try to work this out in subtractive modeling method first with students as we get ready to start, because typically subtractive modeling method kind of makes sense, especially if anyone's done any woodworking or kind of made any parts. A lot of manufacturing processes are subtractive, so that's kind of where you have material and you're taking away material to shape something, and that's kind of where I'm going to start off with this. So start 2D sketch. I'll click on the front face. I'm going to end up drawing one of the parts here, as I know I've got these notches on the corners to remove, and then I got this one notch down here that's kind of longer in width but a little shorter in height. So what I'm going to do is I'm going to click on rectangle, and I can draw to what one of those would be. Now looking at my dimensions, so to kind of see what's the size of one of these particular blocks, so it's 1 inch wide by 1 inch tall, and to kind of make this a little bit faster, I'm going to go ahead and click on rectangle, and I'm going to go ahead and draw the other shapes as well while we're at this. So we know this is going to be 1 inch tall, and we're going to be 1 inch wide. So the other one is down here. I'm going to click back over to the rectangle tool and draw this shape. So some of the dimensions I will need, looks like it's 0.5 off of the ends and 0.5 tall. So one of the easiest ways to dimension, a lot of times you can click on one line and it'll dimension the width, or usually what I do is I have the students click on one line, click to another, and you can set those distances. So 0.5, if we use I usually like to have the students get used to utilizing the dimensions that are provided in the sketch. You never really want to assume. Granted, we could mathematically calculate that this width is going to be 3 inches wide, but also on this height you may have to click on 2 lines in order to get that to work. So 0.5 for the height and 0.5 off of each side. I'll say finish sketch, and then what I can do is I can extrude. What I'll do is I will click to highlight any of the profiles. So I'll click all 3 of these, and you'll notice that the one here in the middle I'll leave alone, but I'm going to choose the cut option. So the cut option, and it's going to go the same distance as what the depth of the first particular case was. You're going to see in red the removal of the material and kind of get a preview of what the shape will look like. You'll say okay, that looks good to you. So there's the main part. Then I can say start 2D sketch, click this side to look at doing my square tab that or my rectangular tab that kind of comes off of there. And as I look, I can look to start to draw and pull some of those features. So click on rectangle, draw that in there, and then look at some of the dimensions. So it looks like 0.5 off of the front and 1.5 wide. So off the front to the first edge of this. So it'd be 0.5. And then the width for this, 1.5. As far as how far distances for dimensions go, doesn't really matter too much. So looking off of those, I get 0.75 off the height from that edge, and then I'm going to have 0.25 for the height on that notch. So I'll say finish sketch, extrude. Now in this case, we're going to do an additive process since we're going to add to this. So and it has a depth of 0.75 in there as well. So adding material is additive, and then going through and anytime we're cutting or taking material away is subtractive. And there could have been another way that you particularly created this part. So once you have this one done, I'm going to very quickly show you another way that this could have been done. And another way could have been, so depending upon student preference or even your own preference, is you could always have drawn, and I'm not going to worry too much about the dimensions at this point, because mainly I'm just trying to draw to kind of give you the concept here, is you could have drawn the front profile of the shape as so, and went around and look at applied the dimensions. So in this case, dimensioning from here to here would give you 4. And then taking a look at the height of being at 2.5, utilizing some of the same dimensions and applying some of the same aspects as well. So you can kind of see how this would maybe speed some things up later, but it could also be a little different in terms of how you want to see the model get created. So finish the sketch. Notice it's all purple. It will be fully extrude. It will be fully constrained, and then I can extrude this to be at that point. So here I have not removed any materials, and then I can click on the side, placing that square tab, inputting the correct dimensions, and looking at finishing up this particular model. So you can see two ways of creating the same part. One way to verify if we did is going through the iProperties menu, clicking on the Physical tab, clicking Update. Our volume is a 16.531. And on our first model we created, our iProperties, 16.531 for the volume. Tells you these parts are identical, but you can see we had to do 3 extrusions in this first method that we tried, and in this one we only had to do 2 extrusions. So one way to see the efficiency is by checking the browser history and seeing how many features did you have to use in order to create the object. So we can see that second method is a little bit more efficient, which is kind of what they're describing in this activity. And why do you feel it was the most efficient? Which one did you use? Of course, students would be answering this, but it's one of those things to consider as you actively model and create different parts